So tablets out, Microsoft Teams open. You should see a 7th hour pre-calculus tile in your Microsoft Teams. I loaded everybody in yesterday. Is anybody missing that tile? Great. Go ahead and click that bad boy. In the navigation pane here on your left, you want to find the class notebook where it says class notebook and click on that. It'll take a moment for the OneNote notebook to load into that navigation pane on the right. Once it does, you'll see this little editing button here with the drop down. From the drop down, pick Open in Desktop App. Once you do that, your OneNote should automatically open up and load in the new notebook. My advice to you is while the OneNote is open, go ahead and close out your notebook from last semester. I've already closed it on my end, and I know that we've had some people last semester having syncing issues because you had notebooks open for classes that were no longer active, and then it was giving you sync problems. So I would close my first semester notebook. Colin.
Oh, where do we click once we get to that screen?
So where it says editing here, hit the drop down and pick Open in Desktop App.
Yeah, mine's on Oh, so is it like the editing should not be available? Mine says the editing isn't available, but right there is.
Yeah, yep. Just from the little drop down. Yep. Maya, did you get it? Yeah. Okay. Yeah, I know you can't do anything in the OneNote notebook here, but you just click that and it should open up the app on your computer and load everything in and good to go. Reagan, you're making some faces. Did you get it or no? Okay. You girls got it?
Yeah, she's got it.
All right. Cool. While you guys are getting that stuff all sorted, I'm going to pass these out.
So I can delete them.
I would just close it.
It's already, I think it's already gone.
I would just close last year's notebook, get that thing out of there.
We're still doing this? No. No.
Oh.
We're not doing this.
It'll be okay, I promise. Yes, back for me. I just don't want to see all this stuff going all the way over there and coming back.
My account is gone. Like my Google account. I can't get into Google. I have Olivia back there. I don't have.
All right. You guys got into your OneNotes, got that set? Okay. Again, my recommendation to you is to close out your notebook from last semester. To do that, click your drop down in OneNote, right click whatever notebook that is you're wanting to close and pick the close this notebook option. Nothing is deleted, nothing is lost. It just, OneNote stops trying to sync to that notebook and it'll save you some sync time and maybe some headaches for things are trying to sync when they can't sync and yada, yada, yada. So the class syllabus, I'm not really going to talk about because it's literally the same syllabus as last semester where all of you hit me. So it's going to work the same way. No surprises. Today, we're going to start talking about Chapter 6, And we're really going to do just a little limited piece of Chapter 6. Chapter 6 is all about more identities. Now, we did identities in Chapter 5. And when we did the identities in Chapter 5, we did like the simplifying, and we did verifying identities, we did solving. We're not going to do any of those things for these new identities that we're going to talk about here today. So mostly what we're going to be doing is trying to find exact values for like sine, cosine, tangent of non-unit circle angles using these new identities. Okay? So again, I gave you the identity sheet right now with the new identities on it. If you look in OneNote, I have the same sheet in OneNote. If you happen to lose yours or you misplace it or you just need another copy or whatever, there's another one there. So if we look at our new identity sheet, you'll notice that we're going to have a few new types of identities. We have these sum difference identities. We have double angle, power reducing, and half angle identities. So that's going to be what we're going to be talking about in Chapter 6. And we're really going to just do a limited sampling of these things. We're not going to derive any of these identities. We're not going to do any verifying or simplifying or solving with these identities. Instead, we're really just going to be doing some like evaluating sine, cosine, and tangent of stuff. So let's just go ahead and do some examples of kind of what we're going to be asking you to do, or what I'm going to be asking you to do. So one of the kinds of problems I'm going to ask you to do are going to sound like this. It's going to tell you the identity I want you to use. So in this case, a sum or difference identity. And we're going to use that to find the exact value of cosine 75. Now, when we say exact value, what are we going to need to be using? If we're doing trigonometry and we want the exact value of something. What tool do we have to use to get an exact value of sine, cosine, tangent of something? Oh no, guys. All through first semester we did this. All the time. If I want an exact value of something, what am I going to have to use? It's round. There you go, the unit circle. Okay, so when you hear exact value in one of these trigonometry problems, you should be thinking, I need to be using my unit circle. The problem is, if I go and I look at the trig expression in question, is 75 degrees a unit circle angle? Is that an angle that's on our unit circle? Go look at the back of your identity sheet. Check. Is it on there? No. Okay. So what am I going to be doing? What should I do then, Mr. Kulik? Well, it says to use the sum and difference identities. So since I'm doing cosine of something, I'm going to be looking at the sum and difference identities 3 and 4. And what I want to try to do is I want to try to rewrite 75 degrees as the sum or the difference of two unit circle angles. So let's look at our unit circle and see if there are two angles on the unit circle that we see that add to give us 75 degrees. So look at your unit circle, look at the angle measures in degrees. You see two of those that are going to add to give you 75 degrees. Nathan.
Pi over.
We'll just use degrees, homie.
Oh, 30 degrees, 45 degrees.
Perfect. 30 degrees and 45 degrees. Excellent. So what about if we want to do subtraction? Are there two angles on here that we could subtract to get 75 degrees? $120 minus 45. Excellent, Colin. Does it matter which pair of numbers I try to use? No, I'm going to get the same answer either way. So let's just say for the sake of argument, we used 30 and 45. Everybody okay with that? Oops. So what we can say here is cosine of 75 degrees equals cosine of 30 degrees plus 45 degrees. Easy so far, right? All I did was break up 75 into the sum of two unit circle angles. Mr. Kulik, would you ever give me a problem where I couldn't do that? Where you asked me to use a sum or difference identity and there just wasn't, I couldn't do it with the unit circle angles? No, man. It's always going to be possible. If I'm going to give you a problem that are possible. Is it possible with any number for you to do that? Okay, if I give you 12, is that a problem that's possible to use? No, right? Has to end in a 0 or a 5 because all the unit circle angles end in either 0s or 5s. Everybody's okay with that? So what I'm going to do now is I'm going to go look at my cosine of x plus y. So really, in our case, we said x was 30 and y was 45. So I'm just kind of thinking about that. So on my paper, then I'm going to write cosine 30 times cosine 45 minus sine 30 times sine 45. Everybody's okay with how I'm applying the identity here from my sheet? So far, so good. Any questions you guys have yet? Now, what I have is 1, 2, 3, 4 trig expressions that I need to evaluate. So cosine of 30 degrees, cosine of 45 degrees, sine of 30 degrees, and sine of 45 degrees, those are all unit circle problems, right? How do I find the value of cosine of 30 degrees? I go to my unit circle, I locate 30 degrees, and then which coordinate is cosine? x. Very good. Thank you, Nora. So that's just going to be square root 3 over 2. And then if I look at sine of 30 degrees, that's the y coordinate at 30 degrees. That was 1/2. And then to do cosine of 45 and sine of 45, I'm going to do the same thing. I'm going to go back and I'm going to look at my unit circle. I'm going to find 45 degrees. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. So I'm just going to go and copy those now onto my problem. So far, so good? Not a big deal yet, right? Nothing too difficult. Now what I need to do is I need to simplify this expression. So I see two operations going on. I see multiplication, I see subtraction. Which one do I have to do first? Multiplication, because that should come first in our order of operations. So if I look here, I have root 3 over 2 times root 2 over 2. So I see two fractions being multiplied. How do I multiply two fractions? Top with top, bottom with bottom. Very good. Okay. So 2 times 2, that's easy. But how do I do root 3 times root 6? How do I multiply two radicals together? Root 3 times root 2. Right? Because that's the top. How do I do that? Nora? What was that? That's correct. Right? Hopefully you remember from your Algebra 2 class that root A times root B is root A times B. And then we'll do the same thing with the other fraction. What do I get when I do 1/2 times root 2 over 2? Over 4, though, right? So 1 times root 2 is just root 2. 2 times 2 is 4, so I have root 2 over 4. To subtract two fractions, what do I have to have? Nathan. Great. Do I have one? Yeah. Okay, so how do I subtract two radicals, though? How do I do root 6 minus root 2? Is that true? No. You can't do nothing with that. You just write them next to each other and we're done. Maya? Certainly. Does everybody feel okay with what I just did here? Not a big deal, right? It's like, well, it's okay, whatever. Now, if you had chosen to do cosine of 120 minus cosine of 45 instead, what would have happened? You get the same answer, right? It'll end up being the same answer, I promise. Doesn't matter whether you think of it as an addition problem or a subtraction problem. You get the same result, which is lovely, right? So far, so good? Let's do another example. So again, using sum and difference identities, Find the exact value of let's make it a little bit sneakier or more challenging here, and let's use sine of 5 pi over 12. Oh no! What makes this one a little bit harder? It's in radians, right? We have the fractions in there. Yuckarooskies. What do you suppose is my suggestion for the first thing you do?
Can we do radians, degrees?
Yeah, let's do that. How do we do that?
180 over pi.
Very good.
I got to think which way.
Somebody studied over break or something.
Oh yeah.
Okay. So if I multiply those, the pi's are going to cancel because I have one on top and one on bottom. There's a 6 that can go into 180 and also into 12. And then a 2 that can go into 2 and 30. So I'm left with just 5 times 70, or 5 times 15, which is 75. So sine of 5 pi over 12, that's just the same thing as sine of 75. So again, I can think about this as an addition problem or a subtraction problem. Just for the sake of argument, I'm going to do that. I'm going to think about it as 120 minus 45 just to show you that, like, whether you do an addition or subtraction doesn't really matter. Everybody's okay with what we've done? So we converted that radian measure to degrees, and then we turned that degree into the sum or difference of unit circle angles. And now I'm going to go to my identity sheet. We're doing a sine, so we're going to be looking at either the sum of angles or the difference of angles for sine. Which one should I be looking at with what we just wrote? The difference, because I wrote 120 minus 45. So this is like 120, and this is like 45, 120, 45. Everybody's okay? Okay. So let's write that in then. So there's me using my identity. That's all I had to do with it. I just used it as a formula, basically. Now, what do we have to do? Go to our unit circle to evaluate sine of 120, cosine of 45, cosine of 120, sine of 45. Who can look at their unit circle and tell me what sine of 120 is? Square root 3 over 2. Excellent job. What's cosine of 45? Square root 2 over 2. Very good. Cosine of 120. Negative 1 over 2. And then sine of 45. Square root 2 over 2. Any questions on how Colin did that? Again, this is like a first semester skill, like a chapter 2 skill. We should be pretty good at looking values up off the unit circle, right? Not too terribly difficult there. All right, let's multiply our fractions together. What do I get when I multiply root 3 over 2 times root 2 over 2? over 4 though, right? And then the next one, well, what do you notice here when we have minus a negative? What's that going to mean? Yeah, it's going to mean plus. Very good. And then what's 1/2 times pi over 2? I'm sorry, root 2 over 2. 1/2 times root 2 over 2. Yes, root 2 over 4. And we have a common denominator. Oops. Come on, come on, come on. Does OneNote ever just not want to erase for you sometimes? Yeah, it's like, come on, man. And we're done. Whoa! How you guys feeling about this? It's not too bad, right? Pretty straightforward. We might ask you to go the opposite direction. So if we have sine 47 times cosine 23 minus cosine 47 times sine 23, and we will being asked to write this as a single trig expression. So when I look at this, I notice that the 47 happens twice. I'm going to think about that as like my x. And the 23 happens twice. I'm going to think about that as a y. So when I look at this, I really am seeing sine x times cosine y minus cosine x times sine y. Does that make sense to you guys on how I'm looking at that? Now, when you're actually doing the problem, do you need to write this step down that I'm writing down right now? Not really. I'm just doing it to kind of explain to you what I'm looking at, what I'm seeing. So once I've done this, what am I going to do now? I'm going to go to my identity sheet and look for which one of them is equal to sine x times cosine y minus cosine x times sine y. Which one of those identities is equal to that one? SD2. Very good. So that's going to equal sine of x minus y using SD2. And x we said was 47 and y is 23. And then 47 minus 23 is just 24. That's my answer. Single trig expression. All that mumbo jumbo is just sine 24. Is that okay? It's not bad, right? All right, let's do some examples using the power reducing identities. So that's on the back page. So I'm going to go to the power reducing identities on my back page. I'm going to locate the one I need, which would be which one? Excellent, because that's the one with cosine in it. So using that, I can say that's equal to 1 plus cosine of 2x. In our case, what is x? That's 60, right? Everybody so far so good? Now I have to go ahead and simplify that. 2 times 60 is 120. And now I'm going to evaluate cosine of 120. To do that, I go to the unit circle. What's cosine of 120 on the unit circle? It is negative 1/2. Very good. Now, look at what we have here. We have this fraction inside of another fraction. Yuckarooskies, right? Let's simplify this so that we don't have fractions inside of fractions. To do that, what I'm going to do is just multiply the top and bottom by the denominator of the little fraction. So 2 times 1 is 2. 2 times negative 1/2 is negative 1. And then 2 times 2 is 4. And then 2 plus negative 1 is 1 over 4. And we're done. What do you guys think on that one? Yeah, not too bad, right? In general, this chapter should be, the things that we're going to ask you to do anyway, should be pretty easy. What if we ask you for cotangent squared of negative 165? Again, we're supposed to be using power reducing identities. Do you guys see a power reducing identity for cotangent squared on your sheet? Uh-oh. What are we going to use? Well, I know that cotangent squared has to equal 1 over tangent squared, right? Those are reciprocals. So that must mean it's equal to the reciprocal of the tangent squared one. Is everybody okay with what I did there? So if I had to do secant squared or cosecant squared, what am I going to do? The same thing, just to make a reciprocal of sine or cosine, whichever one is the one I need. Everybody's cool? No biggie? Okay. So that's going to be 1 plus cosine 2x over 1 minus cosine 2x. Again, the first thing I'm going to do now is to multiply that out. So 2 times negative 165 is negative 310. And now I want to find the exact value of cosine of negative 310. Oh no! There's no negative angles on my unit circle. What on earth should I do with that? No, easier than that. Oh my goodness. I mean, that's not one, it's not negative 310. It should be 330. Yikes. Let's find an angle that's coterminal to it, right? By adding or subtracting 360? What should I be doing here, adding or subtracting? Adding, because I want to get a positive angle so it lands on the unit circle. So I'm just going to add 360 to those. And that I can definitely do. That's a unit circle value. When I look on the unit circle, what's cosine of 30 degrees? Excellent. Oh no, I have that same fractions inside of fractions thing again happening. What do I do to take care of that? I need to multiply by the denominator of the little fraction. Oh my goodness. Okay. Remind me next time we have to finish this up. But you guys should be able to work on 1 through 10 from the homeworks. That won't be due until the Sunday after next. Like the 12th or whatever.